All right, we are going to do Objective 3 today. We are going to factor a sum and difference of cubes. This is your first Algebra 2 lesson, okay? This is your first Algebra 2 lesson. This will be on your SOL. Do you understand that? To factor a sum and difference of cubes. That will be on your SOL. So you need to make sure you understand this. I will also say it has a formula that goes with it that is not on your formula sheet. So what do you got to do with that formula? You got to memorize it, okay? So hopefully today I'm going to help you memorize it. Question about this? All right, everybody have this down? Okay, so we need to go over our perfect cubes. I feel very confident that you understand your perfect squares when we were doing a difference of two squares. And what do you notice, too, about today's lesson? Today's lesson, we are factoring what? A sum and a difference. So if it's a cube, it can be a sum or a difference. If it's a square, it can only be what? A difference. If it's a square, it can only be a difference. Okay? You can't do a sum of squares. But for a cube, it can be a sum or a difference. But I feel very confident that you all know that, the square root of 81 is 9. And the square root of 64 is 8. And the square root of 25 is 5. I feel very confident that when you look at x squared minus 25, that you see, okay, x squared is perfect, and 5 is a perfect square. But I'm not sure how many of us recognize our perfect cubes. So I want to go over, okay? I'm going to give you the first 10, okay? So 1 cubed. 1 times 1 times 1 is 1. 2 cubed. 2 times 2 times 2. 8. 8 is a perfect cube. 3 cubed. 27. 4 cubed. 4 times 4 times 4. Do we know how to put this in our calculator? It is 64. Go, Kirby, go. Okay, let's talk about how to put this in our calculator in case you need it. Okay? All right. So we got 64. Let's see if we can do 5 cubed. So we're going to put in 5. Everybody do this with me. We're going to put in 5, and we're going to use the arrow button, the caret. We're going to raise it. Does everybody know what I'm looking at? It's a little arrow above the division sign. Okay? Raise it, and you're going to raise it to the third power. And you're going to hit enter. What is it? 125. So you're going to hit 5. You're going to hit the arrow above the division, the little caret. You're going to raise it to the third power and hit enter. You get 125. Okay, what is 6 cubed? 216. What's 7 cubed? 343, and I need you to recognize that. Okay, that needs to be how many before today. If you saw the number 343, you wouldn't understand, really what that is. Okay, when you see 343, you need to go, oh, that's a perfect cube. Okay, where are we at? That's 6, 7, 8 cubed. 512, 9 cubed. 729, and 10 cubed. 1,000. Okay, and you may want to, just so you can keep up with your numbers, like this is 1 cubed, this is 2 cubed, this is 3 cubed, this is 4 cubed, 5 cubed, 6 cubed, 7, 8 cubed, 9 cubed, 10 cubed. Are there more? Yes. Okay. You can do 11 cubed, 12 cubed, but if I've got all the ones up to 1,000, that's pretty much what you're going to see. Okay, that's pretty much what you're going to see. But I will tell you, it doesn't mean there won't be others, but that's just the ones all the way up to 1,000. Okay? All right, so it does have a formula. I'm going to give you a second to write all this down, and then we're going to put it into action. There are 5 examples total today, just in case you are wondering. Okay, 5 examples total today, just in case you are wondering. this is how I remember our formulas. If it's a sum, okay, if it's adding, then my first factor is going to be adding. It's going to follow the problem. And then it switches signs here. Okay, so I always say plus, plus, minus, plus, plus, minus. If it starts with a plus, it's going to start with a plus here and then flip. Over here, if it's a subtraction, if it's a difference of 2, then it's going to start with a difference and then flip. Okay, so plus, plus, minus, 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 plus. That's how I remember it. What do we know about the b squareds? They're always plus. Okay, they're always plus. So I'm going to break this down into 3 steps for you. Okay, because we have to memorize this formula, because it's not on our formula sheet, we're going to write the formula every time we do it today. And I promise you, if you'll write the formula, number 1, you'll memorize it. Number 2, it'll make your problem so much easier. Okay, so step 1, this is a sum, so we're going to write the formula. A plus b, so if it's a sum here, it's going to start with a sum, times quantity of a squared plus, minus ab plus b squared. Step 2, I'm going to define a and b. If I knew what a and b was, it'd make it pretty easy to just plug in, correct? So I'm going to define a and b. And so a is just going to be the cube root of the first term. So my question is what number cubed, what can I multiply 3 times by itself to give me x cubed? What times what would be x cubed? X. X times x would be x to the 3rd. Does that make sense? Okay. And then to find b, I'm just going to take the cube root of the second term. So what's the cube root of 27? 3. It's on your list. Let me mention this though. If you wanted to use your calculator to find the cube root, how do you find the cube root in your calculator? Anybody remember? Math what? Math 4. Math 4. Okay? Does that make sense? Like if you wanted to find the cube root of 27, you could go math 4 and then put in 27 and hit enter. So what's the cube root of 27? 3. 3 times 3 times 3. So wherever I see an A, I'm going to plug in an X. Wherever I see a B, I'm going to plug in a 3. So let's do it. So I have an A first, so what will I plug in? X, and then I have a B plus 3. Then I'm going to square the A, so what will I have? X squared minus AB, which would be, so minus, what's x times 3? So minus 3x, and then I'm going to square my B, which is, 3 squared is 9. Okay? And there's your answer. 3 steps. Step 1, write the formula. Step 2, define A and B. Step 3, plug in. And someone said, Ms. Corns, can't this trinomial break down further? Can't that break down? And I'm going to tell you right now, it's one of those puzzles that can't work. You can try all day to figure out something to multiply to be 9 that adds to be 3, and it's not going to work. Do you understand that? So I'm going to tell you right now, once you plug in, you're done. Okay? Now, I am going to do the check step. Okay? You're going to be required to check on half of your problems. I recommend that you check on, I recommend that you check on all of your problems. If you want to make sure you're right, you need to check on all of your problems. But for those of you who feel like you can do this, and if you do it correctly, should that be right? I mean, if you can write down the formula, and if you can define A and B, and if you can plug it in, it should be correct. But I'm going to show you how to check one time. So x squared minus 3x plus 9. Okay, so here we go. How do you multiply a binomial with a trinomial? Can you foil? Can you foil a binomial with a trinomial? No, but you can distribute. So I'm just going to times the x to each of these, and I think that's what you were saying. Draw your lines. Yeah, sure, Miss Corns. And then you're going to do what with the 3? Do the same thing, all right? And then we're just going to combine like terms. So let's do it. X times x squared. X to the 3rd. X times negative 3x. Negative 3x squared. Thank you very much. X times 9. 9x. So far, so good. Now I'm going to do it with the 3. 3 times x squared. And I'm going to go ahead and I'm just going to put it underneath here because they match. Because in a minute, I'm going to combine them. Does that make sense? Because they're like terms. Okay? 3 times negative 3x squared. Or 3 times negative 3x. Negative 9x. 3 times 9. 27. Now, when we combine like terms, I'll get an x cubed. What happens here? What happens here? And what are you left with? Is this what I started with? Yes. Does everybody understand that you can't do FOIL to multiply a binomial? And I highly recommend. You might have a problem that asks you to multiply a binomial and a trinomial on your SOL. Some people, how many will admit you probably are not going to remember the formulas by the time May comes? So what did they do? If it's a multiple choice question, what do? They do the check step all the way back to the question for A, B, C, and D and see which one works. They just multiply them out. Okay, so you need to know how to do that. If you're going to be one of the ones that's not going to remember the formula, then you're going to need to know how to do the check step to work backwards to get the answer. Okay? How are we doing on time as far as lunch goes? What time is it? 12:06. Thank you very much. Okay, so I think we can get through example 2 for lunch. So, this is a difference. Someone asked me earlier, how do you know if it's a sum and how do you know if it's a difference? Yeah, if it's a sum, it's going to be a plus in the middle. It's going to be adding. That's what sum means in math. If it's a minus, it will be a difference. Okay? So, what's step 1? Write the formula. Step 1's write the formula. So, here's my formula. If it's a minus here, then my first binomial will be a minus. Then I will switch it to a plus. Plus b squared. Okay? Now we are going to define a and b. So a is the cube root of the first term. What's the cube root of 8x cubed? 2x. Very good. What's the cube root of 125? 5. Someone said, do you need to do like negative 125? And here's what I told them earlier. The formula will do your signs for you. Do you understand that? So just work the number. Okay? Don't worry about the signs. Okay? Don't worry about that that's a negative 125. Just take the cube root of 125, and when you plug it in, it will fix your signs for you with the formula. Okay? Then we're going to plug in. So I have a, so what will I plug in? 2x minus 5 times the quantity of a squared. So does that mean I square the 2, square the x, or square both? Both. Very good. So what do you get when you square 2x? 2x times 2x? 4x squared. When you square 2, you get 4. When you square x, you get x squared. Okay? Then I'm going to times these two. What do you get when you times 2x times 5? 10x. And then when I square the b, what do I get? 25. And there's your answer. And you don't have to go any further. I don't know that I have ever seen a cube that can go further. Any questions on that? Okay, so I'm going to leave you with this one, and I need to fix it. There's a typo. Let's make this 125. I'm going to leave you with this one for lunch. and you can work on it, and then we'll solve it when we get back from lunch. Okay, 2 examples left after this. Okay, so if we factor this, first of all, you need to recognize that these are cubes. Okay, does everybody understand that 125 is a perfect cube, a cubed is a perfect cube, and 1 is a perfect cube. So this is a sum of cubes. So step 1, write your formula. What's the formula? A plus b times quantity of minus ab plus b squared. Okay, step 2 is define a and b. So a is going to be the cube root of 125a cubed, which would be 5a, and b would be 1. And then from there, all you got to do is plug it in. Okay, so this would be the quantity of 5a plus 1. Thank you. When I square the a, you got to square the 5 and square the a. So what would that be? 25a squared minus, multiply these two, 5a plus 1. And you're finished. How many were able to get there? Good. Did you just do 5a squared? Yeah, that's a common error. So make sure you square the 5 and square the a. You got to square both. Okay? All right. 2 more. And I want to change this. Let's make this a to the 6. Okay, let's make this a to the 6. So my question to you really quickly is a to the 6 a perfect cube? What number can I multiply 3 times to give me a to the 6? A squared. A squared times a squared times a squared. Everybody understand that? Because what's a squared times a squared? A to the 4th. And what's a to the 4th times a squared? When you multiply powers u. So what will that be? A to the 6. So does everybody understand that the cube root of a to the 6 would be a squared? A squared times a squared. And if you struggle with that, you divide it by the root. This is a cube root, so if you divide this by 3, the cube root of this would be a squared. Yes. No, thank you for asking. When you multiply powers, you add the exponents. Does that make sense? So it would be a to the 6. Okay. Good question, though. So don't multiply the powers. When you multiply the powers, you add the exponents. Okay. Any other questions? All right. Yep. So check there today sometime. Okay. All right. Okay. So step 1, write the formula. What will our formula be? A minus b. If it's a minus here, it's going to start with a minus. And then what? A squared plus ab plus b squared. How many are already starting to memorize? Like you've gotten them down. So the more times you do it, the more times you'll get it down. All right, let's define a and b. So the cube root here, remember I told you you can just take 6 and divide it by the root. Divide by 3, and that will help you know what the cube root of a to the 6 is. Does that make sense? If it's a square root, you would divide it by 2. If it's a 4th root, you would divide it by 4. Does that make sense? And so forth and so on. So this will just be a squared. A squared times a squared times a squared. Okay? What's the cube root of 64b cubed? 4b. And so now we're just going to plug in. So what will I have? A squared minus 4b times. Very good. Any questions on how to take a squared and square it? Are we adding the exponents or are we timesing them? When I multiply, I add the exponents, right? But when I raise a power to a power, what do I do here? You times them. And so that would be a to the fourth. Okay? So that would be a to the fourth. Plus, let's multiply a squared and 4b. What do you get? 4a squared b. You just smush it together. No, it's not a b squared. It's just a single b. I'm just taking this 4 and this b and timesing it with a squared. And now just write it alphabetically. That's why I fit the a squared in between. Okay? And then plus, now be very careful here. What do I get when I square 4b squared? 16b. I'm just squaring this right here. When I square, I'm squaring the 4 and I'm squaring a b. Squared. 16b squared. Okay, how many were able to get there? My question is if you didn't, do you know where I missed you from? Where did I lose you, Landon? Okay, so I'm just plugging in 4b into this spot. So when I plug a 4b into the b, does that make sense? When I square the 4, I get 16. And when I square the b, I get b squared. Does that make sense? Okay, and here's your answer. So I feel like we need one more, and it has purpose. So here's our last one. It has purpose. I promise it has purpose. Anybody have any thoughts on this? I don't want to do decimals. Okay. Okay, so these are not perfect cubes. So, okay, think back to what we did Friday. The best factorer in the whole world does what? Does this have a GCF? So let's do that first. Let's take out a GCF first. Let's go back to Friday. Let's just take out a GCF. Okay, everybody do that right now. What would the GCF be? 2. So let's take out a 2. So if I take out a 2, what would I be left with? 216, very good, plus what? X to the 9th. Now my question is are you finished? You need to recognize, are those perfect cubes? Is 216 perfect? Yes, it is. 216 is perfect. What is the cube root of 216? I will even help you out. The cube root of 216, so that's going to make a 6. And someone said, Miss Corns, it's backwards, like your X is at the end. You might think that too. So you don't need to switch it around. Your A is going to be the cube root of the first term you see. B is going to be the cube root of X to the 9th. Is X to the 9th perfect? Any multiple of 3. And I told you, if you struggle with knowing, what can you simply divide by? You can divide by this guy right here. So what's the cube root of X to the 9th? X to the 3rd. Does everybody understand that? X to the 3rd times X to the 3rd times X to the 3rd will give you X to the 9th when you add them together. Okay? So, go from there. Finish it out. This guy can go even further. Write your formula down. Yeah, he is important. He is a factor. Okay, remember he's like a little brother or sister that has to come on to our answer. So for right now, I'm just going to drop him. And then I'm just going to work these two to make this right here. What's our formula? A plus B minus AB plus B squared. What happens if you don't write your formula down and you don't define A and B? It's going to get really lost, okay? So this is a crucial step, okay? So let's just plug in. So this will be 6 plus x cubed, square the 6, so what will I have? 36 minus 6x cubed. Now be very careful here. What do I get when I square x cubed? I told you a second ago, am I going to add them or am I going to multiply them? What will I do with the 2 and the 3? Multiply them. When you're multiplying, you add the exponents. When you raise a power to a power, and let me say this, another way to write, give me another way to write 5 squared. Write it twice, right? So give me another way to write x cubed squared. Write it twice. And when you're multiplying, what do you do with them? Does that make more sense to write it twice? If that helps you, write it twice. Okay? It's going to be x to the 6th. Anybody have x to the 5th? I had lots of those in second block. Okay? Does that make sense? How many were able to get here all the way? A couple. So if you didn't, do you know where you went wrong? The perfect student is the one that makes mistakes and figures out where you went wrong. Okay.